Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about VR kinematics modeling in virtual reality in medicine. See here, the virtual reality kinematics modeling. Actually, it starts from the world to room, tracker source and tracker receiver, HMD, left eye, left screen. Also we have right eye, right screen, fixed transformation. The second one is variable transformation. And we have variable transformation side, object 1 to object n. Also we have receiver hand. Okay. While coming into this object hierarchies, it allows models to be partitioned into hierarchy and become dynamic. Segments are either parents, higher level of object, or children, lower level objects. The motion of a parent is replicated by its children but not the other way around. Example, the virtual human and the virtual hand. At the top of the hierarchy is the world global transformation that determines the view of the scene. See the virtual reality kinematics modeling. See the model hierarchy, a static model viewpoint database, and also we have segmented model. Here consider football player. We have upper body as well as lower body, and we have upper right arm, left arm, and upper leg, left upper leg. Also we have right lower arm, left lower arm, right lower leg, and left lower leg. For fixed transformation, for variable transformation, we have to consider both based on our virtual reality applications. See, object hierarchy for a virtual hand. Here, the transformation matrices can be compounded to obtain the motion of a fingertip versus the world coordinates. Here, TW palm of T is given by the glove tracker, and T palm 1 of T and T1 2 of T, T2 3 of T are given by the sensors on the glove. See here, in this VR kinematics modeling, homogeneous transformation matrices, object position, transformation invariants, object hierarchies, and finally we'll have viewing the 3D world. With the help of this above 4 elements, we can view the 3D world in a perfect manner. See, in this VR modeling, the rendering pipeline for kinematics, we have applications, geometry and rasterizer. In this geometry functional substages, we have model and view transformation, lightening, projection, clipping and screen mapping at the last. Here, model and viewing transformations. See here the instances, world system or coordinate. Why do we use this world system coordinate? We have to map the real world with the real world, so we use the world system coordinate. See the instances for virtual ball and instance 2 of virtual ball and instance 5. See the differences. Okay. See here the view transform matrix. It captures the position and orientation of the virtual camera in this VR world, and it maps the world coordinates to camera space is called eye space. The camera is located at the origin of the camera coordinate system and looking in the negative Z axis with Y pointing upwards and X to the right. See camera system of coordinates X, Y, Z, and T camera fingertip 2 of T and T camera fingertip 1 of T. See the view transformation. See the camera flyby. Here the user interactively changes the viewing transform by changing the position and aim of the virtual camera. It is called flyby mode. And the second one is projection. From this model and view transform, we have lightening, projection, clipping and screen mapping. Under this, we have to discuss about projection here. And in this projection transformations, models what portion, volume of the virtual world the camera actually sees. There are two kinds of projections, parallel projection and perspective projection. VR uses perspective. See here the parallel projection and projection plane, projection reference point and perspective projection. With the help of this projection transformations, we can get the perfect transformations at the user side. C. Perspective projection transformation. Here we have projection reference point and projection plane. We have to map both. If the projection reference point is at the origin of the system of coordinates and the projection plane is at D, minus D, then the non-invertible perspective projection transformation matrix is here. We have to calculate both invertible as well as non-invertible based on the VR applications. And second, perspective projection transformation. See here the projection reference point and clipping plane, ITF, and in the lower side we have RBN. Here Z equal to N and Z equal to F. Only what is within the viewing cone, also called fulcrum, is sent down the rendering pipe. Here the portion of the virtual world seen by the camera at a given time is limited by the front and back clipping planes. And we have canonical mapping because we are using kinematics modeling. Here the second projection transformation maps the viewing volume to a unit cube with extreme points -1, -1, -1 and 1, 1, 1. We have to concentrate both positive as well as the negative side. This is called the canonical view volume. See the transformation. Okay, here next one is clipping. Geometry, we have model interview transformation, lightening, projection, and fourth one is clipping here. Clipping transformation, see the unit cube and scene clipping to the next one. The vertex V1 is replaced by new one at the intersection between line and the viewing cone. The last one is screen mapping. See here, the scene is rendered into window with corners x1, y1, x2, y2. Screen mapping is translation followed by a scaling that affects the xy coordinates of the primitives objects but not their z coordinates. Scene coordinates, screen coordinates plus z epsilon -1, 1 are passed to the rasterized stage of the pipeline. And finally, we'll get screen mapping with real world. Thank you.